Wait 1 second. Is it live? Yeah, it is live. 1 second. I need to do some of the things. Yeah, it will be useful for me. Otherwise, it will be a bit tough to. Hey, what happened? It is coming. Let me first. Sorry for the waiting, guys. I need to do that. Otherwise, I can't know what thing I'm doing. I I need to do some of uh, this. See, please do like, share, and subscribe. Sorry for the interruption 2 times. Now it will be no interruption for you guys. Okay, thanks for again coming. I'm sorry for the interruption and again. Sorry. Now this time no interruption. I'm sure with all connections. Okay. 1 second. I'm doing some settings so that I will not be in trouble again. If I don't do this settings, again I'll be in trouble. So in order to avoid those things, I will do some of the settings so that I don't need to do again and again. Yeah. Okay, I'm all set now. Now I'll start the session. Let me 1 second. No interruption and again. Cancel. Now I was saying triangle law of addition, right? That is, first take a vector A. Let me call this vector. Wait 1 second. Let me call this vector A. Let me call this as vector B. Okay. Okay. Let me call this vector B, vector A, and the resultant of these two, if you add graphically, the resultant should be like this. If you have to connect, or the from the starting point to the terminal point, you have to connect those 2 points. This is the starting point, as I said in the video. The starting point is this and ending point is this. So you have to draw arrow like this. This is C vector, which is called, it is called the resultant vector. Okay, this is called the resultant vector. And now I'll show you this with an easy example. Your mom asked you to bring a Maggie packet. You're here. You went to the shop. This is the vector A. Again, you went to another bangle shop. Your mother asked to bring that. So you went like this. This is vector B. This is vector A. And the distance should be like this. From the initial point, this is the end point. So the distance between these two points is like this. This is a C vector, which indicates that um, there are this is a resultant vector which indicates the distance between two vectors mutually. Okay, now I'll show you next law of the meaning of the statement looks like this exactly. Okay, as I said, the example holds to these statements. Please do read this statement and keep it in our mind. And now we'll do some problems. Okay, the first question of today is: a girl moves with 3 meters east, then she takes 90-degree left turn and moves 4 meter towards the north. Find the displacement of the girl. The options they are given is 5 meter 53 degree east of north, 5 meter 37 degree east of north, 5 meter 37 degree west of south, 5 meter 30 degree west of south. Which option will be correct? Wait. Hey. What they have asked: a girl moves 3 meters towards east. Which direction is east? This is a direction of east. How much? 3 meter. Again, the girl takes 90-degree left turn. Means like this. She moves like this in the northward direction and moves 4 meter north. This is 4 left turn, and she moves toward the north in 4 resultant vector. The resultant vector is sum of the sum of vector A and B. The sum of two vectors is the resultant vector. I wanted to say this: the resultant vector is actually the sum of the first two vectors. Okay. Uh, 1 second, 1 second, 1 second. I did something mistake, I think. One second, guys. I only got confused with that question. How to do that? 1 second. See, this is a question, right? The answer to this question will be The answer to that question, I did some wrong. See, I'll show what I did wrong. This is the first. The girl moved from west to east, that is 3 meters, and the girl moves straight, that is 4 meter north, and this is the vector c, resultant vector. The resultant vector is the vector, as I said. One second, guys. Yeah, I am all set. The answer to that question, that is the c vector, will be the using Pythagoras theorem. I can write it as, it is hypotenuse square. So 3 square plus 4 square is equals to 5. The answer to that question will be 5. Sorry, the c vector is equals to 5. And now c vector is 5. One second. One second. Now you need to understand a little more bit more thing, that is, this is the vector, as I said. It moves like, sorry, I only got confused. This is the thing that I have given. They have also missed one data. Sorry, when I was giving question, I missed some data. When she moves from uh, east to west, the angle is 53 degree. So by this, one second, I'll draw some big. This is this, and this. This is 50, 53 degree. This is 90. This is, what will be this? Um, 90 plus 53, 37 degree. This is okay. Sorry, guys. Got confused. I needed to give this question after the parallelogram law, but I'll give it to you now itself. This is the answer, and let's see whether the live is again not struck right. One second. Yeah, the live is not struck. I was checking in my laptop just, and as I said, this is the answer. And what options they have given? See, uh, a girl moves 3 meters towards the east and takes 90-degree left turn and moves 4 meter north. Find the displacement of the girl. What would be the answer? The answer would be 5 meter. The answer to that would be 5 meters. And 5 meters 37 degree. That is the answer to that question. 37 degree east of north. 37 degree east of north. How I came to know? Using direction. Yesterday I said she had what there was find the displacement, right? This will be 90 degrees each angle, and the girl has moved like this, take like this, and this is north, this is east, yes, correct. This is 50, this is 33, 70. The girl has moved 37 degrees, means they have asked this particular question. Think the girl moves 37 degree east of north. From north, the girl moves 37 degree east. That is the meaning of that statement. Okay. And now we'll do parallelogram law of vector addition. What does this mean? The parallelogram vector law of addition is also a kind of law of vector law of addition. Before I go to the parallelogram law of vector addition, I need to specify some of the things. Conditions. What are the conditions for adding vector? First of all, there is two conditions. First, head of the first vector must touch. Head of the first vector must touch the tail of the another vector. Head of the head of the first vector should touch the tail of the second vector. This is the first. I have written in shortcut because there is no space in mobile. And the second thing is draw a net displacement. That is, draw an arrow from the starting point to the end point. It is called the second condition for adding vectors. And geometrically triangleize like this. Like this, as I said. And second, say C vector A plus B. I'll represent C vector is actually A plus B, right? Yeah. And I need to teach you some of the things. That is, this is a vector A thing. If the vectors move like this is called anti-clockwise direction. If the vector move like this is called clockwise direction. Clockwise is taken in negative, whereas anti-clockwise is taken positive. This you must remember. You will be taught this type of things in your maths class. Okay. Now, um, I need to explain you some of the things in triangle law. Just I gave a brief idea of the triangle law of addition. Now we'll go to the in-depth, and next we'll move to the parallelogram of vector addition. Okay. Uh, this take this vector A, vector B, as I said. Sorry, wait 1 second. Now I'll introduce the concept of shifting in. I have introduced to you shifting of vectors. Now again I'll explain the shifting of vectors first, and again we'll move to the in depth of triangle law of vector addition. Okay. What I say, shifting of vector is generally, if the vector is like this, say this vector is vector A or vector B, whatever you want. If I want to move this, it must be moved parallelly. So if I move like this, sorry 1 second. This right, I have moved like this in a parallel of same magnitude and same direction, but you should not represent like this second moved vector. That is, shifted vector should not be represented like this. How to represent shifted vectors? shifted vector will be represented like this in dotted manner of same magnitude and same direction like this. If they mention it is called shifting of vector. This concept I have explained to you now. Okay, please do go through this concept. Now take vector b. This is vector b, this is vector a. These are, there is angle theta between them. Now I want to shift this vector like this because the condition says that the first condition of vector addition of vector says that the head of the first vector should touch the tail of the second vector. Where it is touching, it is not touching. So in order to make them touch, I use the method shifting of vectors. I'll shift the vectors like this. I'll erase for some while because no space here. Yeah, what is this? This line also got erased. Yeah, this I have shifted. Let it be this also. Again, you'll get confused. Okay, this is another kind of. Okay, let it be this. Then the resultant of this is like this. As I said, C bar. C bar is like this. Okay, this is A bar. This is B bar. This is C bar. C bar is equals to A bar plus B bar. Or let me name this as A, B, C. A, AC bar is equals to CB bar plus AB bar. That is the answer. Now I'll erase all and again I'll draw the diagram because the space is congested. And this is a resultant vector. You can move this vector also here, right? Anything can be done with anything you can draw. And I'll draw perpendicular to this. Okay, let me take this angle as theta, that is 90 degree. Okay, wait, this is no space. I'll write 90 degree. Right, I'll not explain that 90 degrees thing. This is 90 degree. Okay, and this angle between them is also theta. And now one second. Let me name this as A, B, C, D. Sorry, A, B, C, enough. This is, let me take as D. Okay, I'll. So if we consider the triangle ACB, a right angle triangle. Okay, ACB, remember that ACB, and if ACB, let's take sine 180 degree. Sine, sorry, oh, somewhere I'm missing this topic, right? One second, guys. What have done something mistake? If you take sine somewhere I saw man in the if you take sine theta, that is equals to h by sorry not h. What is that? What I said, AC B. If you take sine theta, opposite, that is C bar by opposite sine theta. If you take angle like this, opposite by it. One second, guys. This topic I have seen somewhere, man. One second. That thing I have. Yeah, and I was saying this, right? This, and the total is 180 degree straight line it becomes. And if you take 180 degree, that is 180 degree, this is 90. If you take perpendicular, it will become 90. This is 90, this is so if you take 90 using sin theta and cos theta, some formula will be derived. That formula is, I'll explain the sin theta, cos theta probably tomorrow. I don't know where I wrote that derivation. I'll see you that tomorrow. The formula will be r square resultant or c square is equals to, one second, the resultant will be ab into a square plus b square into theta cos theta. This is the thing where you will get in the um, using that equation. Okay, I'll say that to you in the next class. And I'll explain you first some of the important thing. If you take a let you take an three vectors like in this direction, 1 2 3, you will shift this vector like this. You will shift like this, sorry, this one vector, this is another vector, this is another vector. You will move this vector like this, and let this angle be alpha. So if you move this is 180 degree. This angle, what will be this angle? This angle will be 180 minus alpha, right? This is the angle that comes. And if you move vector, sorry, this will be like this direction will be like this, the direction of this vector will be like this. If you move this vector, let this be gamma, and what will be this 180 minus gamma, right? And if you move this vector down, the angle between them is beta. Let's think beta, gamma, and angle between this is alpha. So using this, I'll derive the area. What is the formula of area? Of into base into height, right? This is the formula of area. Now here B is, let's we take 1 second. Let me take this as B vector. Let me take this as C vector. Let me take this as something like A vector. Yeah, this is A vector. And now using the area formula, that is half into C into height. What is this height? If we draw like this vector, the straight line, and the straight line goes. Let it draw perpendicular in between. Let be this height. Let it be height of a triangle. And the formula that gave for us is half into C into H. That is that what I showed now. So using this, I'll derive the formula of sine 180 minus beta. What is beta? Beta is this thing. If you sorry, wait. This was a triangle, and I increase this. This is beta, which I took. Okay, sine 180 minus beta will give rise to, if sine 180 minus beta, I'll give a small trick to remember. N into 90 plus or minus theta. This is in the form, right? 180 degree minus beta. 180 degree is a multiple of 90 degree, right? So if it is even, it is 2 right here. If it is even, keep the co-ratio same. If it is odd, change the co-ratio. What is co-ratio? Sine co-ratio is cosine tan cot, and secant cosecant. These are the co-ratios. Means I'll show you how. The full name of sine is sine. The full name of cos is cosine. If you split this, I'll show you, right? Sine. The the name of this is sine. What is the full name of cos? Cosine. This is the full name of the cos, that is cosine. We read it in a short term as cos. So please do remember the full names of this. And what sine 180 minus theta? It is a 2 multiple, right? It is even number. So do not change the co-ratio. What is the sine co-ratio? Cos. We should not change. And whether sine in the second quadrant, 180 minus beta, right? So whether sine is positive or negative, sine is positive in the, sorry, yeah, sine is positive in the second quadrant. So we will write as sine of beta is equals to sine beta is equals to sine beta is equals to um, h by a. H is equals to, here by this you can write h is equals to a sine beta. This is the formula of h, okay? And you can derive the area of other, like for a, this I derived for beta, right? Now I'll derive it for gamma. Half into base into c sine gamma. This is the if you want to find gamma, okay, the h will be one second, h will be b sine gamma, sorry, gamma. For h will be b, sorry, a b sine theta, sine alpha, for alpha, okay. Now if you combine all these in one thing, it will become sine beta by, sorry, first you divide all by a ABC. Divide everything. AC sin theta, BC sin alpha, AB sin gamma. Divide all by ABC. Then that H will be sin beta by B is equals to sin alpha by A, and H will be sin gamma by C. This will be the result, and this is only known as Lami's theorem. I have taught you Lami's theorem in the way of triangle law. And see, the shifted vectors look like this, right? I will not represent in the line. The shifted vectors look like this. If they ask, the resultant vector will be like this, R, okay. If they ask if this is O is at equilibrium, how much force does, let be this A, this B, how much force does C needed to be applied? The C needs to apply equal force as that of A and B, then only the two vectors come in this direction. Now I'll teach you the parallelogram law. Let's take this vector, so this vector and this, this mainly the important thing in triangle law of vector is actually the Lami's theorem. I had taught to you. Wait 1 second. This is not a diagram. This is the thing. Before I explained, I thought this is that was triangular. No, this is not triangular. Now I'm explaining the parallelogram law. Okay. I told you I'll explain tomorrow. That is, I'll explain today itself. That will come in parallelogram law. Okay. This is a vector. I'll move with the help of shifting vector due to the rule. It comes like this, and this is the resultant vector. And let this be some angle theta. This will be theta minus alpha, right? Or let this be, let this be alpha, let this be alpha minus theta, right? And if I draw perpendicular like this, it comes, right? I was saying as a bit some while ago, if you move this vector also, it will be same as I said. It's the resultant vector, and this will be, if we take if I said this is perpendicular. No, this is not perpendicular. This is theta, and this will be 90 degree. What? This will be 90 degree. Okay. Okay. Now, we'll find the some formula. What I gave r is equals to r square. R is equals to root under of a square plus b square plus c square. This is a formula I gave you right that time. I'll explain that formula using the help of parallelogram itself. I'll not explain using triangle law. Okay. This, this, and this, and this, and this. Okay, right. This is 9. Oh, sorry. I can't write like this. This, 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 this. If I draw perpendicular, oh, wait, I'll not draw arrows. Yeah, this is a perpendicular. Now it looks like perpendicular. Now I'll draw arrows. Yeah, this is a resultant. This is 90 degree. This is theta. This is theta. This is alpha. Alpha minus theta. Now I let this be C. This be D. This be A. This be O. Now keep in mind this. Uh, Keeping in mind this, let us consider let us consider triangle OCD. Okay, triangle OCD. In that triangle, OC square is equals to OD square plus CD square. What I have done, I have using Pythagoras theorem for OCD. I have made OC square is equals to OD square plus CD square. Now OC square. Wait 1 second. OA OD can be splitted as OA plus AD. If you can remember the diagram which I drawn, OCD, I was taking a full triangle. In that OD consists of OA plus AD, right? That, sorry, AD, right? This is AD. Sorry, this is AD, right? This was the thing I wanted to know. That I wanted to say you. Then OD is that if I write OC square in terms of that, OA plus OA plus AD square plus CD square. This is actually OD. I split OD into two things. I want to know OA, right? OA AC, that I wanted to know. This extra I have done perpendicular. So now using that, first I'll split this OA plus AD square. If when I split this, the answer will be OA square plus AD square plus 2OA into AD. This will be the answer to that splitting. And let me put all those in one and add CD to it. OC square will be that. Wait 1 second. OC square is equals to OA square plus AD square plus 2OA into AD in plus CD square. That will be the answer, right? For that, let you keep this mind. And now let us consider triangle CAD. Let us consider CAD, the perpendicular thing what I draw, that we consider. Okay, and let we now cos theta. Cos theta is equals to that only using cos theta and sin theta. Now we will derive that thing I was saying. We derive in triangle law. Now I am doing in parallelogram law itself. Cos theta. The theta is the angle between AC and AD, right? So the cos theta will be AD by, what is cos theta? In order to remember this, I'll give a small trick. To remember all the ratios. P B P whole divided by H B. This is sine, cos, tan. Reverse of this is sine, cosine, cosec, cosecant, tan, cot. That will be reciprocals. See, cos is this, right? Now we need base and height. In this diagram I said this is 90 degree, this is theta, and this is C, this is AD, this is hypotenuse, this is perpendicular, and this is base, right? They have asked what they have asked, sin cos. If you forget again, write it again here itself and write like this. This is H, B by H, B is AP. So we write cos theta is equals to AD by AC. Then if you do cross multiplication, AD is equals to B cos theta. Okay, that will be the answer. Keep this again. Sin theta also, if you do for that, will be equal to CD. If you do this for sin theta, you'll get the result as CD is equals to B sin theta. In order to find the OA plus OA plus CD, I have done this. Okay, now we have got red results. AD is equals to B cos theta, and CD using sine. This is cos. The cos I have shown, sine I did not show. You can do by yourself. B sin theta. Okay, and the result OC square is equals to OA square plus AD square plus 2 OA into AD plus CD square, which I explained. These are the three results you need to keep in your mind. And now, if you replace AD in the place of AD and CD in the place of CD, then the answer, as I said, OC square. In that equation, if you place AD is equals to B cos theta and CD is equals to B sin theta, the result will be R is equals to OC square. OC square is equals to R. Let us assume OC square is equals to R. Then the result will be R is equals to under root of A square plus B square plus 2 cos theta to a b cos theta. It will be like this. If you want to, you can write in another way also. R square is equals to a square plus b square plus 2ab cos theta. This will be the answer. Okay. Now we will learn the magnitude of the resultant. What will be the magnitude? Magnitude. This was the thing I was explaining. The parallel, if two vectors are represented by two adjacent sides of a parallelogram in magnitude and direction joined by tail to tail, then the resultant will be given by a diagonal of a parallelogram. As I draw a diagram like this, right? This is a thing, and this both are parallel. And if you draw like this also, this is a parallelogram. That's what they are saying. If two vectors are represented by two adjacent sides of a parallelogram in magnitude and direction joined tail to tail, then the resultant is given by the diagonal of a parallelogram in magnitude and direction starting from the common intersection of two vectors. This is the thing I have explained in detail. Wait 1 second. And I'll say the magnitude of the vector of the resultant vector. Two vectors A and B acting on a same point simultaneously can represent the adjacent side of the parallelogram. Then the angle between them is theta. Diagonally of the parallelogram passing through the same point is representing resultant of these two vectors in this direction. The diagonal of the vector, that is OC, is equals to the a plus b, that is equals to r. OC square is equals to r square, that is r is equals to a square plus b square plus 2ab cos theta. Using that we can derive many things. Now I want to find out what is alpha. What? This was like this, right? This is a resultant. I want to find out this is alpha. This is alpha minus theta, I said, right? This I want to find out. Now I will find out using tan alpha in triangle OCD. Tan alpha is equals to CD by OD. CD by OD. That is equals to CD by OD is equals to CD by OA plus AD. And we have just found out OA plus, this is not B, this is D, A, AD, that is, 1 second, sorry, this is sin theta is AD is equal to sin B sin theta, yeah, that is AD. So you will get as tan alpha is equals to B sin theta by OA plus B cos theta. And simply remember this formula: tan alpha is equals to tan inverse of B sin tan inverse of B sin theta by A plus B cos theta. Everything which I have written is correct. Don't get confused. And now we will do some question. Now till now we have read theory, we will now do question. A vector A has magnitude of 10 units and points due west, while vector B has same magnitude and point due to south. Find the magnitude and direction of the A plus B, A minus B. Specify the direction related to west. This is a homework for you. In tomorrow class, I'll check your homework, and now then we will move to the polygon law. No, you do this homework. I'll explain it to you in the tomorrow's class. Now, shortly, I'll explain you the 1 second. The polygon law of vector addition or tailhead method, that is to add more than two vectors in parallelogram or this uh, triangle you are adding only two vectors, right? In polygon law you will add more than two vectors. How to add those? See, I have, this is a vector. In polygon, how many sides will be there? Right, that many sides, but the closing side right in an opposite direction. If we take like this, like this, like this, one two three triangles, the same triangles will become, and this side is the closing side, which and nobody will ask you more questions on the polygon law. So you need to remember this is a closing side. What? This is a closing side of a polygon. It's a closing side, 1 2 3 4 5. Yeah, fifth side is the closing side of the polygon. And now the polygon law of vector addition. If a number of vectors are represented in a successive side of a polygon, both in magnitude and direction, then in taken in opposite order of the closing side of the polygon represent the resultant side, both in magnitude and direction. What I say, closing side represent the resultant in magnitude and direction. The addition of these three arbitrary vectors A, B, C, let we name this as A, B, C, shown as a drawn now. And now this is the polygon law. That's all. No question rather than this. No thing. Now commutative and associated law of vector addition. Vector addition is commutative. That is, vector A plus vector B is equals to vector B plus vector A is same, right? If I add, I'll show you, A plus B is equals to B plus A. How? If I take 4 plus 3 is equals to 4, 3 plus 4, everything is same, right? That is commutative law. Vector addition is associative. How? If we, if we add a vector A plus vector B plus C is equals to vector A bar plus B bar into, sorry, plus C bar. This is same, right? 4 plus 3 plus 4, 7 plus 4 is 11, and here 4 plus 3 7, 7 plus 4 11, same 4. This is 4. Wait, I'll show you with example itself. 4 plus 3 plus 4. If you add like this, 4 plus 3 plus 4, that will be same, right? 11 11. That is the thing what they have said. And now I will explain to you unit vector in detail in tomorrow's class. After we solve, we need to learn, sorry, wait 1 second, we need to learn this in types of vectors, unit vectors, which unit vector we will learn this in tomorrow's class, which is important. I need to say you that I cap, J cap, K cap, something about that, modulus, etc. I'll say that, and in the next class we will see that is resolution of vectors, components of vectors, and many more. Okay. Till then, see you. Bye bye. Please do like, share, and subscribe to the channel for more updates for more videos like this. Okay. Thank you guys. Bye bye.